Hi, this is Janak Reddy Dubbaka. Physics, NEET Physics quick revision, that is formula revision. Up to now, we completed two chapters, that is motion in a plane and center of mass. Now we are going to enter into another chapter, that is collision. There are two lectures in this chapter. This is collision part 1. So very very important. NEET students, see, most of the students neglect these chapters: motion in a plane, center of mass, collisions, and rotatory motion. From these chapters we can expect at least 4 to 5 problems. That too, 90% of the problems from these chapters are formula based only. If you know the formula, you can answer that one. See, already we finished motion in a plane and center of mass. Now this is a chapter third one, that is collisions part 1. See, in collision there are three types of collisions. One is elastic collision, inelastic collision, perfectly inelastic collision. In elastic collision, kinetic energy and momentum both are conserved. Therefore, kinetic energy and momentum both conserved only in elastic collision. Here, coefficient of restitution is equal to 1. In elastic collision, every collision momentum is conserved, but here kinetic energy is not conserved. But here, the bodies never stick together. Here, coefficient of restitution is in between 0 to 1. Perfectly inelastic collision, here also momentum conserved, but kinetic energy is not conserved. After collision, both the bodies are stick together and move with common velocity. Here E is equal to 0 for perfectly inelastic collision. See, here coefficient of restitution, E is equal to V2 minus V1 by U1 minus U2. Here V2 minus V1 means relative velocity of bodies, relative velocity of separation after collision, and this is a relative velocity of approach before collision. So very very important one. E is equal to V2 minus V1 by U1 minus U2. Is here head-on elastic collision, one dimensional. See, here before collision, this bodies having velocity U1 and U2. This is during collision. After collision, their velocities are V1 and V2. See, most of the problems are depends on these two formulas. See, V1 is the velocity of the first body after collision, that is m1 minus m2 by m1 plus m2 into u1, 2m2 u2 by m1 plus m2, and this is the velocity of second body after collision, 2m1 u1 by m1 plus m2, and plus m2 minus m1 by m1 plus m2 into u2. See, here some special cases. For example, m1 is equal to m2. In that case, v1 is equal to v2, v2 is equal to v1. Means for first body having the velocity of second body and second body having the velocity of u1. Means here after collision their velocities are exchanged. For example, if one body is at rest, here u2 becomes 0, this term becomes 0, and this term becomes 0, and v1 is equal to m1 minus m2 by m1 plus m2 into u1, and v2 is equal to 2m1 u1 by m1 plus m2. See, this is the general formula. We can use both for elastic and inelastic collision. See, here v1 is equal to m1 minus em2 by m1 plus m2 into u1, 1 plus E into M2 U2 by M1 plus M2. For example, if it is elastic collision, E is equal to 1, then put E is equal to 1 here, we can get earlier formula. And also, in elastic collision, the E value may be in between 0 to 1. If E value is given, we can substitute. These are the two formulas for in terms of coefficient of restitution. These two formulas we can apply for any collision, elastic or inelastic or perfectly inelastic. See, elastic collision E is equal to 1, and inelastic collision lies between 0 to 1, and perfectly inelastic collision E is equal to 0. See, this is also very very important one. If the body is having equal mass and second body is at rest, then ratio of velocities after collision, it's a very very important one. V1 by V2 is equal to 1 minus E by 1 plus E. See, many time direct question given on this formula. See, when second body is at rest, fractional decrease in kinetic energy, that is change in kinetic energy by initial kinetic energy, that is 4m1 m2 by m1 plus m2 whole square. So very 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 important one. 4m1 m2 by m1 plus m2 whole square. And the next one, and kinetic energy retained by the first body, that is delta ke by ke retained. Retained means 1 minus fractional energy loss. This becomes m1 minus m2 by m1 plus m2 whole square. This is also very important one. Many time the formulas problems are given directly based on this formula. This is uh, this is the formula for fractional decrease in kinetic energy, and this is the kinetic energy retained by the first body. Next one, impulse means change in momentum. This is also general formula we can apply for any collision. m1 m2 by m1 plus m2 into 1 plus e into u1 minus u2. Therefore, here perfectly elastic collision E is equal to 1. Inelastic collision lies between 0 to 1, and a perfectly inelastic collision E is equal to 0. And also loss in kinetic energy 1 by 2 m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 whole square. See here, in elastic collision E is equal to 1. If you put E is equal to 1 here, 1 minus 1 0. Therefore, kinetic energy loss 0 in elastic collision. Why? Because kinetic energy is conserved. Total kinetic energy initial is equal to total kinetic energy final. There is no loss of kinetic energy, and these are the formulas we can apply for any collision. This is for impulse. Impulse means change in momentum, and loss in kinetic. See, this is also very important one. Consider a ball falling from certain height h. Let E be the coefficient of restitution between the ball and the ground, and the ball rebounds again and again, finally comes to rest. For example, the ball is falling from a height h. After first rebound, it rises to height h1, and from that height it falls and rebounds to certain height and finally comes to rest. In this case, velocity after nth collision, Vn is equal to e to the power of n into Vn is equal to e to the power of n into u, where u is equal to square root of 2gh. Why? Because it is falling from a height h. And another one, total hn, height after nth collision, hn is equal to e to the power of 2n into h. Very important. For example, after first collision, what is the height raised? Therefore, n is equal to 1 e square h. After second collision, e to the power of second collision, e to the power of 4h, like that. And the total distance traveled. Therefore, while it is falling from a height h, and after number of rebounds and finally come to rest, what is the total distance? Total distance 1 plus e square by 1 minus e square into h. This is also very important. Total distance is h, but total distance is 1 plus e square by 1 minus e square into h, but total displacement is h. Why? Because it is falling from a height h and finally comes to rest on the ground. Total displacement is h, but total distance is 1 plus e square by 1 minus e square into h. And total time taken, see, total time taken, and this is 1 plus e by 1 minus e into square root of 2h by g, and this is the total time taken. And the momentum imparted to the ground, that momentum is equal to total momentum 1 plus e by 1 minus e into p, where p is the initial momentum, that is m into u. Therefore, p is equal to m into square root of 2gh. Next one, perfectly inelastic collision means perfectly inelastic collision. After collision, both the bodies move with common velocity. That common velocity formula very important. V common is equal to m1 u1 plus m2 u2 by m1 plus m2. With this is a first part from collision. Very important. Only formulas. Okay, these are the formulas. Very important. We can expect at least minimum 4 to 5 questions from chapters motion in a plane, next center of mass, collision, and rotatory motion. This is the part 1 from collision.